Hey everyone, this is your friendly neighborhood math teacher, Mr. Bennett. Today we're going to cover 2.5, and from the learning targets at the top, you can see that our goal is to find the proportion of values to the left, to the right, and between two different boundaries within a normal distribution. And again, that's kind of key here, is the fact that they are normal distributions. And so if you haven't seen the movie Back to the Future, it's pretty great. It's pretty much a classic. So if you haven't seen it, go watch it at some point, not during class, but at home this weekend or something, go watch it. Before our situation, we can see here, it says after accelerating for 20 seconds, a DeLorean sports car has a wide range of speeds that it can achieve depending on traction. The distribution of speed follows an approximately normal distribution, so again, that's key there, with a mean of 80 miles per hour and a standard deviation of 7.7 miles per hour. So question 1 says label the appropriate values on the normal distribution. So we're given this graph. Our center line here at 0 standard deviations, okay, that's where our mean goes. And our problem tells us our mean is 80 miles per hour. And for the sake of this, I'm just going to put miles per hour down at the bottom here, since we know that we're working in speeds. And then a reminder, right to the right is 1 standard deviation, so it's the mean plus 1 standard deviation. So since our standard deviation is 7.7, 80 plus 7.7 is 87.7. And then we'll find our mean plus 2 standard deviations. So again, add another 7.7. So that gets us to 95.4. And then again, plus 3 standard deviations at another 7.7. So that gets us to 103.1. And then on the left-hand side, going the opposite direction, we're now minus 1 standard deviation. So we're going to subtract 1. So 80 minus 7.7 would get us to 72.3. Subtracting that again to get to minus 2 standard deviations would be 64.6. And then to 3 standard deviations, 56.9. And remember, when we label these normal distributions, we call this a normal distribution, capital N. And then in parentheses, our mean, so 80, comma, our standard deviation, 7.7. So we want to make sure we label that so we know what our graph is. And then a reminder, just kind of a quick reminder, right? In between 1 standard deviation is 68% of our data. Within 2 standard deviations is 95% of our data. And within 3 standard deviations, and I'll move that in a second, so you'll get the picture there. Within 3 standard deviations, it's 99.7% of our data. Okay, so that was our empirical rule, right? Our 68, 95, 99.7 rule. So that's just important to remember. And so we're going to go through this, and these first two, we're going to try to use that empirical rule to solve. So questions 2 and 3, we're going to try to use the empirical rule. So question 2 says, what percent of the runs will give the DeLorean a speed greater than 87.7? So again, because it says greater than, right, that means to the right of 87.7. So we're going to find 87.7, which is right here at that 1 standard deviation mark. So I want everything to the right of that. All right, I want all of this in here. And so there's kind of a couple of different ways we could look at this. And so one of the ways we could look at this, I'll go over kind of 2 ways just so you can see that there are multiple options here. So kind of whatever your brain and your mind can think of. So the first one I'm going to talk about, it's kind of one we've done already, and that's the fact that this first half, right, all the way up to my mean, right, the first half of my data is 50%. And since I know this middle section in here is 68, that means each half of that is 34%. And so if we have 50% all the way up to the mean, and then a bonus 34%, that gives me a total of 84%. Now the problem is that 84% is to the left of that line, but in reality I want this stuff to the right. And so because of that, I can think of this as the entire thing, right, 100% minus that 84%, which would give me a total of 16%. Okay, so that's one way to think about it, if that helps kind of make sense of that. The other way we could think about this is, again, we know we're trying to find this shaded part to the right. And so if that's the case, right, I can think about the fact that if I look at both of those shaded parts on both sides, that's basically my entire graph minus this middle section. And so what do we know about the middle section? Well, the middle section is 68%. So I could also think of this as 100% minus that 68% in the middle, and that gives me 32%. But again, that's split between the left side and the right side. So if the 32% is the left and the right, and all I want is the right-hand side, right, this one right here, then I know that it must be that 32% cut in half. So we do 32% divided by 2, which gives me 16%. Okay, so this is just kind of two different ways of getting to that same conclusion, just kind of depending on how we want to break this up and the kind of puzzle pieces we want to try to put together. So either way would be fine. Just kind of wanted to show you that there's not necessarily just one way of finding this answer. So either way, as long as we get to 16, right, that's what we're looking for. Question 3, what percent of the runs will give the DeLorean a speed between 64.6 miles per hour and 87.7? So this one's a little bit more obvious, right, between those two. So it's in the middle. So when we look at our graph, we have between 64.6, which is right on the left-hand side here, and 87.7, we already have that line. And so now, I'm just going to bump up my highlighter really quick. So now we're looking at all of this in here. And so we can, again, think of this kind of a couple of different ways. One of the ways we can think about this is the fact that I know all of 2 standard deviations, so I'm going to use purple here. So from negative 2 standard deviations to positive 2, all of that is 95%. And so really the shaded part I'm looking for here is all of that just minus this little part over here. So what we're going to do is we're going to say, okay, I know it's minus that part. Well, could I find what both of those on either side are? And the answer is yes, because all I'm then doing is taking out this middle section. Right? If I'm trying to find these 2 side parts, I need the whole thing minus that middle section. So we're going to take our 95% that we know it is. We're going to subtract out that middle 68%, which gives us 27%. And so if that's the case, then that means that this section here and this section here combine for 27%. Well, again, I don't need both of those sections. I just need the first one, right? I need that one there, and then the green stuff in the middle to get from my two orange lines, right? 64.6 to 87.7. So because of that, since I only need half of it, we're again going to take that 27, we're going to divide it by 2, and that's going to give us 13.5%. So this purple section kind of off to the right, or sorry, the left, is 13.5%. So we know that first purple section is 13.5, and what do we know about this middle green section? Well, again, it's kind of hidden right now, but that middle section is that 68%, right? That whole from -1 to +1 standard deviations is 61%. So we know that we have the 13.5% plus the 68% in the middle, which gives us a total of 81.5%. And again, there are several different ways you can go about doing that. That's just probably the one I think would be easiest to think about. Clean this up a little bit here. And now question 4 says, what percent of the runs would give the DeLorean a speed less than 68.45 miles per hour? So again, I want to highlight the fact that it says less than means to the left, left of 68.45. And so what we want to notice here is 68.45 isn't on my graph, right? I don't see it there. I see a 64.6, I see a 72.3. So where would 68.45 be? Well, if we think about it, that's about 4 away from 64, and it's about another 4 away from 72, right? 68 plus 4 would be 72. So it's about right in the middle here. So 68.45 is about right in the middle between those two. And so how do we find that? Like, we don't know, exactly where that's at, because I don't have, a good estimate here. So one of the things, right, we can think about is, okay, well, it looks like it's about halfway between -2 and -1 standard deviations. So maybe I just cut that section in half, right? Because it looks like it's about halfway. So if we do that, right, then what I really want to do is figure out how big is that section, right? How big is the section from -2 to -1? And again, we kind of just did the work on that by taking the -2 to +2 section, all of this, -2 all the way to +2, and we said that that was 95%. We subtracted out the 68 and then divided by 2. That was what we did right here. Okay, that part right there is what gave us this left section. So if that whole section is 13.5, well, if I want to split that in half, I'm just going to divide it by 2. So if we split that section in half, 13.5% divided by 2, and we've got 6.75. I'm going to use the calculator just to double check that. 13.5 divided by 2, 6.75. Cool. So 6.75. And so that means that we're going to use that for this section here. And then we still need to figure out, okay, well, what is the rest of this, right? All the way out from -2 to the end. And so we can kind of think about the fact that from -2 to -2 is that 95%. So that means the full outsides, right? This left tail and this right tail must be the remaining 5%, right? Because 100% minus 95% gives us 5% to work with. And so if both of those combined are 5%, if I only want one of them, right, I don't need the right one, I just need the left one, and then I'm going to again cut that in half. I'm going to divide by 2. So we're going to take that 5%, we're going to divide by 2, and that gives us 2.5%. So since that left side is 2.5%, we know the middle is 6.75. We're just going to add those together. So 6.75% plus 2.5% is 9.25%. Now, the only problem with this, okay, and so that was all of that logic was good. The only problem is if we actually look a little bit closer at our graph here, and we look at this purple section. So remember, this purple section, I'm going to re-highlight this just so it's a little bit cleaner here. So this purple section, we said, is half of this entire section from the purple and blue combined. And so if we look at those two combined, does the purple actually look like half, or is it maybe a little bit less than half, right? If we're looking at the area, kind of the area of this kind of trapezoid looking shape, this one looks like it's kind of got a lot more. And so even though 68.45 fell halfway, the area wasn't half, right? It looks like it's a little bit less. And so we need kind of another way to get around that. And so I'm going to kind of pause the video here and you're going to play the next one. But we're going to use a standardized version of this graph to help us with that problem. We're still going to answer question 4, but now we're going to talk about something a little bit different.